I'm going to be going over another coding problem today called linked list sum. The problem goes, you are given two non-empty linked lists that represent integers. A linked list of 1, 2, 3 represents the integer 321. Write a function to sum two of these linked lists and return the sum as a linked list. For example, given the linked lists 1, 2, 3 and 2, 4, 7, the sum is 3601. First, we're going to start off by writing the linked list node class. So each node should have a value and a pointer to the next node. So we'll set these over here. And I'm going to give some default values. So I'll default value to 0 and next to none. This problem can be approached both iteratively as well as recursively, and I'm going to go over both approaches. We're going to start with the iterative approach, and the strategy for this approach is that we're going to have a pointer for each list, and we're going to traverse the two lists in parallel. At each iteration, we're going to find the sum and keep track of the carry value, and add these to the resulting list. When we finish traversing both lists, then we're done. Let's code the solution. First, we'll start off by initializing res to an empty node. Then we'll create our two pointers for traversing the lists, P1 and P2. Now we'll create a pointer cur for traversing the resulting list. And we're going to keep track of the carry value, which we will initialize to 0. So now we will want to create our while loop. And we want to loop until we finish traversing both lists. So our condition will be P1 is not none, or P2 is not none, or we still have a carry value. So carry does not equal 0. And in here, we will keep track of the temporary sum. And we'll initialize the sum to the value of carry. And if P1 is not none, we will add that value to the sum and set P1 to P1.next. We're going to do the same thing for P2. So now we're going to set the value of cur to be equal to the sum modulo 10. And we're going to set carry to the sum divided by 10 and take the floor of that. So if this condition is still met at this point, then we're going to initialize cur.next to be an empty node and set cur to be equal to cur.next. And when we finish with this while loop, we can return the result. Now let's try the recursive approach. Since linked lists are recursive data structures, they lend themselves to a very clean recursive solution. When we're trying to think of a recursive solution, we want to break our problem down into two cases, the recursive case and the base case. The base case is similar to the final case, and for us, this occurs when list 1 and list 2 are both none. Then we can just return none and be done. For the recursive case, we want to look at the current values of list 1 and list 2, find the sum, find the carry value, and then construct the new node based off that. And we then want to call linked list sum with the remainder of list 1 and list 2 for the next value of the current node. Let's code this approach. In our recursion, we want to keep track of the carry value, which I'll default to 0. Now let's write our base case. Our base case is when list 1 is none, and list 2 is none, and the carry value is equal to 0. In this case, we can just return none. Now we want to think about what params we want to pass in the recursive case. And next one is what we'll pass as list 1, and I'll set this as none first. I'll do the same for list 2. And now let's build up the sum, which I'll initialize as the carry value. If list 1 is not none, then we'll add its value to the sum. and we'll set next1 to be equal to list1.next. And we're going to do the exact same thing for list2. Now we want to build our new linked list node. And the value of this node will be sum modulo 10. And then the following linked node will be the result of calling this function again with next1, next2, and the carry value, which is sum divided by 10 and the floor of that value. There are some trade-offs when deciding which approach to take. Both solutions have a time complexity of O of n because we're traversing both lists exactly one time. However, for the iterative approach, we're not adding any extra function calls to the stack, so we're saving space there. But I think the recursive approach is a lot cleaner and it may be more maintainable in the future. So depending on which one you value more, one approach might be better than the other. Thanks for watching the video. I'm going to post a link to the GitHub in the description. And if you have any problems you'd like me to cover in the future, feel free to leave a comment. Thanks.